Hi, students. So we are in Unit 3, Lesson 12 of Computer Science Discoveries, and we will be learning about sprite movement today using something called the counter pattern. And that is what you see right here. It is one of the most important uh, constructs and things that they use in programming because it increases any kind of variable by one or decreases it in some cases. So you can we call it the counter pattern because it simply counts up. And in this case, it counts up by one, but it can count up by other um, increments as well. And you'll use this a lot, especially with the draw loop. So we are going to look at this program and make a prediction. And so you can see that this program creates a variable called counter and then uses the counter pattern to make it count up. When you run the program, what do you think you will see on the screen? Now, I noticed that there is a draw loop, and I noticed that there's a background whatever changes happen are going to constantly be covered over by a new background. So we're going to see something as it's happening, um, and not a whole bunch of things on the screen. Text size. That's weird because normally this is a number here of pixels. So normally it's like 14 pixels or 10 pixels. In this case, it just says counter, which is also our variable. And then text is counter, also a variable. And then its location would be these two. If we forget that, I think we can open up the toolbox here and go to text. There we go. So we have what is shown, which is normally in quotation marks, but instead it is calling a variable here without the quotation mark. So it's looking and getting that value. So the XY coordinates is 0, 400. So we know that means we don't go any to the right. We stay right up here and we go straight down to the very bottom of the screen. So down here, there's going to be a number, and it will start at 0. And every time it goes through the draw loop, it's going to be that number plus 1. So it's going to continue to increase by 1. So this looks to me like we're going to see numbers down here that are going to count up until we stop the program. Doesn't look like it ever stops. All right, let's see if we're right. I noticed that the size is getting bigger. I forgot to mention that when I was making a prediction, that the text size is also increasing. Oop. Let me go back to that. So this is interesting. That means that the text size or the number you see is also the number of pixels that text is. So if you were curious as to what a 140, 50, 60 pixel sized text looks like, pretty cool. Eventually it gets so big it will take up the entire screen. I wish I could just pause it. It will not let me do that. Okay, we're going to continue. So hopefully you made a prediction and then ran the program. For Bubble 3, actually a video, it's a very important video to watch. It's not very long. If you have not seen this video, please go ahead and watch it now. Pause me and go watch this video so you'll understand better moving forward what the rest of the bubbles are talking about. All right, going to move along. Bubble 4. Hopefully you watched that video. And we see a plane going up the screen. or I should say a jet going up and a plane going from left to right. And that's what we want to see happen. This says you can write programs using the counter pattern that will animate sprites smoothly. Adding to or removing from a sprite's X or Y property makes your sprite move just a little bit each time it is drawn. Now we've explored that using the X property makes it move across the screen, left to right. Using the Y property controls up and down movement. So let's read the code that makes the jet go up the screen. So we have the variable jet created at 350, 350, which is down here in the corner. And then we see the background. And we see they've commented to make this easy. Moving the jet up is the jet.y. So the y value is what's going to change. And it is changing at a rate of -3 every time the draw loop goes through. So that is they're both moving at about the same rate. I'm just kind of peeking. So that means we want to have the plane going on the x-axis, increasing the x value. And since it starts at 0 and goes to 400, we want to use the +3. All right. We don't need to add the background because that's already been done. We just need to add the variable function here. And let's see, we want to add the property right in the little there. Oh, goodness. I guess I can take that off. We're going to change that to be plain so it matches what's up here that it was named. So plain y equals, and this is an orange, or I guess you could call that orange. So we're going to use the plus operator. And we're going to use that sprite.y again, right there, plain +3. This will make them move at the same speed in just two different directions. The draw sprite command is already there. So at the end of the draw loop, it's going to do both of these with that one draw sprite command. Let's run and see. Should work. Oh no. Oh no, I have made a mistake. Obviously, I said I needed to do the X, but I still absent-mindedly grabbed the Y. It's okay, mistakes happen. Happy little mistakes, like Bob Ross would say. Only we're coding, so I'm sure he would say it if he was a coder too. So we're going to change that to be plain. Try this again. Now we'll try it. Let's see now. Our picture is matching their picture. And both the plane and the jet exit off the screen at about the same time. Now, just for kicks and giggles, if I wanted that plane to move faster, let's make it 7. So now you can see the jet is going a lot faster than the plane. I'm going to go back and make it 3. Since that's what it's supposed to be. And we will click finish. Continue. Moving along to bubble 5. We want to move to the left. If adding to the sprite's x-coordinate makes it move right, how can you make it move to the left, like the fly? All right. So we are going to move the fly a bit to the left each time the draw loop is run. That was the Sprite X. And notice that when we drag that one out there, it knows that we have to give it a value. Automatically puts all that other stuff, the rest of the block there that we need. So the Sprite.x, if this is positive, the most positive, 400, we are going backwards here, which is subtracting from our x value. So instead of doing plus and adding, we're going to do minus. And we need to change that to fly. Fly x minus, we'll do 3. And it says you can make your sprites move faster by adding or subtracting larger numbers. It says the fly in our example moves about twice as fast as the plane. So if we went, last time we were going 3, so I'll do it 6. Okay. I feel like it's moving a little faster, but that's okay. What we want is that we want the program, the fly, to be about the same. All right, so we're going to move along. We did it. You can start to kind of imagine how you can use these skills later on as you're making interactive cards or games. All right, now we have a mouse moving across the screen diagonally. And it says updating both the X and Y properties can make it move diagonally. Imagine there's a grid, right? So if you go down and over, now you've gone that way. So both the Y value and the X value changes. Read the code that makes the mouse go down. Run the program and look at the watchers to see what is happening to the mouse X and mouse Y properties. And I am going to delete the video there so that we can see the watchers. That's down here. Add one more line of code that makes the mouse move diagonally. So right now I see that the background is light green and we are going to have the mouse Y changing. So he is only changing his Y value, not the X. You can see that's what we see over here in the watchers as well. All right. So we're going to reset it. And let's add the mouse.x in here. And the mouse, oops, we need a math variable plus, okay, mouse.x plus 2. Now, since he's moving straight across the screen, usually that means you're going down at the same rate that you are going across, so therefore the plus 2. Let's see if that worked. Yay! If we take the grid off so it looks like the other one, we can see we've got the same picture. Very good. All right, and if we look down here at the watchers, you can also see that they are both increasing simultaneously, the same amount. Okay, finish. All right, bubble 7. Read this program and predict which of the following animations will be produced. And so we're looking at what car is coming from the top and so forth. And I'm just going to look at the blue car. In A, the blue car is coming from the left, going along the x-axis to the right. So we should see that its x value is increasing by 1, or however many they're increasing by. So I'm just going to look down here and see if that's what we see for the blue car. Here we go, blue car. So for the blue car, what we should see is that the x value is actually decreasing by 4. So this one would be the x value increasing. We want to see it the x value is decreasing. So that means that the car is going to be moving from the right to the left. So it's not A, not B, should be C. Let's see if it is indeed C. Yes, so we have our blue car moving from the left to the right because it is going -4 with every run of the draw loop. Good. All right, so for 8, we have 3 activities. One is to make the sprite spin. So this is using a different property, not the X or the Y, but we're using the rotation property. And we're going to find that here. Sprite rotation. And they don't give us a lot of information, but we're going to remember that anything we can use with numbers, we can do the same sort of pattern what we've been doing. We're going to say that the rotation with every draw loop is going to be equal, or get the value of the last rotation plus more. So we'll do +3. We'll see what happens. So my pan is probably going a little bit faster. I feel like it is. So again, if we wanted to slow it down, we can try it +1. And that looks about right. Or +2 even. We don't have to have it doing it exactly at the same speed. Without some kind of watcher or something on the top one, we wouldn't know if we have it the same. So we'll go ahead and click finish because we did get it rotating. And it looks pretty close to me. Now we're going to watch the counter pattern to fix the direction of the motorcycle. It's doing something wrong. Oh, I see. You just barely see it right there. So we'll reset it. We're going to look at the watcher for cycle.x, and it says to add one for cycle y. Let's try that. Is there a way to do that? Do we have a cycle y? Yes. Okay, that worked. All right, so now we're going to run the program. So we had to type that in just so you know. run the program and see what happens to the properties so we can figure out why it disappears. Cycle Y is not even available. Cycle X is really, really, really high. Okay. So what I'm thinking, just because that X gets further and further, so let's try this again. So the X starts off, it does move really fast, but the X starts off slow enough and it increases really fast. Wonder why we cannot see the Y. I'm really not sure why we cannot see it. Let's try it again. Cycle. Didn't like that either. Ah, there we go. So I didn't need to type anything in. All right, so now let's look at it. If we watch the Y, it never starts off at a small enough number that we could ever see. Remember that the Y goes from 0 to 400? So what's happening is Y is starting at 400 and then just continuing to go down, down, down. All right. So we want the Y value to increase. To decrease and get closer to 0 rather than increasing. So we're going to fix it by doing the opposite of addition. We're going to do some subtraction. Oops. I wonder if I could just type cycle dot. Let me just type that. Okay. Yeah, it didn't let me do that. Good to know. If I don't feel like going and finding it, I can just type it in there and it'll fix the block. Alrighty, so cycle.x, cycle.y, let's see if that fixed it. Sure enough. And now you can see what's happening. The numbers at least are there where we can see them for a few minutes or for a few seconds. Continue. Kind of tricky. We had to figure out that watchers thing and the other, and the directional problem. Now we're going to work on rotation direction. When you use the counter pattern for the rotation property, with addition, the object will always rotate clockwise. Sometimes you want it to go in the other direction. So in that case, we would use subtraction. Let's look at these gears. Oh, they're not rotating at all yet. Oh yeah, there's nothing in the draw loop. So we want to look at them in the picture. I see that the red one and the green one are both going clockwise, like a clock. But the blue one looks like it's going counterclockwise. All right, so we've got blue gear, green gear, and red gear. So we'll start off with the rotation. Notice that they use camel case in these names. So blue is lowercase, gear is capitalized with the G. And we're going to make that equal to blue gear. Oops, I forgot the math, the operator there. And we want it to, the blue one is the only one going counterclockwise, so we will make that a subtraction. All right. Blue gear, rotation. I'm not sure how fast that's turning, so I'm gonna just use 5. Make the gears rotate. They look like they're working as one system. So it really doesn't matter so long as they're all spinning in at the same speed. All right, we'll drag a couple of these out here so we can work on them together. And we're going to get the math operators in there. Remember, these both, the red one and the green one, are both going clockwise. So that is a positive rotation, and the blue one is the negative rotation. So red gear, green gear. Okay, red gear dot rotation plus 5. Red gear dot rotation plus 5. All right. This should have them turning in the right directions. Let's see. Yes, looks good. Now they look like they're working like a system with each other. Perfect. That makes me happy. I love gears. All right, continue. Well, that was all for this level, which means that if you've understood all of those levels and you've watched the video, you should be able to come in here and complete your assessment level. And so what you want to do is make all 3 of the fish move as in the image to the right. The blue fish should move the fastest and the green fish the slowest. The orange one sort of in the middle. So fastest fish, slowest fish, and kind of medium fast fish. Right now, only the orange one is moving. That is your assessment. I hope that you do well on it. Looking over here at the key concept tab, you want it to be as much like the instruction, as much like the example, as identical as possible. And if it's quite a bit, if it's obviously different from the example given, but it still is in the right order, with the blue one being the fastest and the green being the slowest, then you will still get a 9 out of 10 for convincing evidence with this particular level. But if you want to get 100, take the time to try to make it identical. And it kind of gives you a hint here as to what you need to do to move across the screen. So if you are a little not sure what to do, come and read over that evaluation rubric and see what it's saying. All right. When you get done with this level, if you would like to do the challenges, it's basically continuing that same picture where you add in making the fish wiggle. That's, shaking back and forth a little bit so they look like they're swimming. And then adding in bubbles. That looks like fun, that rise to the surface while the fish are going over. Pretty cool. Have fun with this, and I will see you in class tomorrow.